I am very happy to have the opportunity to introduce our AI agent framework and to you. I hope I can take this opportunity to explain to you what an AI agent is, its relationship to large language models, what does the ANDA framework do, what can be done, and how ICP and blockchain can empower AI agents. At present, there are many frameworks for AI engines on the market. There are dozens or hundreds of models for large companies and small teams. Why are we still building this new wheel? These frameworks are mainly Python frameworks, much the same, but they also have their own unique characteristics. They mainly serve the application scenarios of Web 2, even though frameworks like Elastic support multiple blockchains, but it is still essentially a framework for Web 2 AI agents. We developed this pure Web3 AI agent framework in Rust. We can use it to develop agents that specifically solve various domain-specific problems. And it responds to complex tasks by flexibly combining different agents. When a single agent cannot solve a problem independently, it can cooperate with other agents, create a powerful problem-solving network. So, in a nutshell, we hope to build a highly composable, autonomous, and permanent memory AI agent network based on, and let's first talk about what an AI agent is. It may be easy to confuse it with AI applications. AI application is more like a tool. It can only perform specific tasks according to the rules or instructions you set, like voice assistants. It can help you set an alarm and check the weather, but if you don't say it, it doesn't take the initiative to do anything for you. An AI agent is a person who can use his own brain in himself, smart employees who work. It can not only understand your request, you can also figure out a way to complete the task by yourself. Even before you say it, it can also proactively identify and solve problems. For example, a real AI assistant, it can be like your personal assistant, take the initiative to organize your schedule, remind you of important matters, even help you make decisions based on your habits. So the main difference between them is AI application. It is a passive. You can only do things according to instructions. There's no autonomy. And agent AI, it's proactive. You can think for yourself, adapt to change, complete tasks independently. So the real AI agent, it marks a paradigm shift from tool intelligence to agent intelligence as a subject intelligence. It is interacting between AI agents. No human involvement is required. So we can imagine in the near future, AI agents form their own social networks. Ultimately, it developed into a super Agi system. Whether it is AI applications or AI agents, their intelligent cores are large language models. For example, DeepStack v3. The knowledge world of big language models comes from training data. The way people use it is called reasoning. Reasoning is stateless. So each input is independent. It has no memory. For example, I told him I was Ace Panda, 1 year old now. Then I asked him how old Ace Panda was. He really didn't know. When you use the AirChat app, you will feel that he has remembered your information. But that memory is external. It is maintained by the AI chat application rather than being maintained by the AI big model itself. Large model inference is essentially a read-only program that runs on AGP. It doesn't remember the latest knowledge you've entered. It is also unable to communicate with the outside world. It's an intelligent processor, different from CPU and GPU. It processes unstructured data such as natural language, images, and sounds. And when we say that AI has very powerful capabilities, this functionality does not come directly from the AI model itself. It comes from AI agents. We can develop all kinds of AI agents based on this intelligent processor, like setting your alarm clock, booking your flights, and so on. So the essence of AI agents, it extends infinitely the programming, perceptual, and behavioral capabilities that large language models lack. Of course, the programming ability here doesn't mean having the big model write a piece of code, because big models are great at writing code. It's a program to digitize the real world. For DeepSeek V, its input and output are all text. So how can you use it for all kinds of tasks? This is actually a magic function calling. Function calling is the interface between large language models and the outside world for delivery. It was designed by the talented engineers at OpenAI. Let's look at this example of a function calling for what the blue boxes are the inputs for the larger model. In addition to regular messaging, it also has an array of tools. The tools array contains a function called getWeather, and there's a description. Tell the big model what the getWeather function can do. There is also a parameter definition. This is a JSON schema. It tells the large model that the parameter format of the getWeather function is larger than that of the model. Now, it's smart enough. It can determine whether to call a getWeather function from the user's input request information. If you need to call, it will be defined in the parameter format. Extract the formatted JSON from the information entered by the user and back to the client side, that is, return to the AI agent. Then the AI agent can call the real getWeather function with formatted parameters, and then we feed that back to the big model. The large model then combines the results into natural language and returns them to the user. So we can see by function calling, large models have access to the latest external information, although it doesn't remember this information. By function calling, large models can also perform external actions indirectly, like setting an alarm clock, buying a plane ticket, conduct cryptocurrency transactions, and more. So the big model is like a brain that is temporarily unable to accept new knowledge, and the AI agent is like its body. Function calling is the nerve cell that the brain interacts with the body, and the big brain interacts with the outside world through the body of the AI agent. The range of capabilities of the AI agent determines the range of behavior of the large model brain. Now, we know the development of AI agent is actually to implement various functions around the function calling interface and make a combined call to them. Complete a task. The framework is designed to make it easier for developers to develop AI agents. A standardized set of definitions of AI agent types and available capabilities is provided in Encore, and implemented these types and capabilities in the engine. Runtime management is also provided. Let's take a look at the core tour type and agent type in under call. They can all be used by function calling. Developers who develop AI agents actually implement these two types of examples. What's the difference? Let's take a look at the input and output of tour first. It's all structured data, and it relies on a state object called base context. Developers don't need to care how the tour is called, but you need to make sure that the input and output structured data is simple enough. Only the large model can handle it correctly. There is also a continued constant on the tour. It indicates whether to pass the output of the tour to the larger model for further processing. The agent type looks simpler. It accepts property text. Its output is basically consistent with the output format of the large model. The agent type also defines the tools. It depends on these tools. Dependencies are detected at startup. The agent type depends on the state object of an agent context at runtime. The context object is a collection of features available at runtime. for tools and agents provided by the framework. Developers can build on these functions, develop a variety of tools and agents. Let's start with the base context on the right. It is a collection of capabilities available to tools. It includes state futures. There is ID user on it. If there is a caller ID, it is an identity of the current engine. The ID user and caller are the username and ID of the requester. There are also things like cancellation tokens. It is a token used to abort tasks. Then there are keys futures. It is a collection of functions used for cryptographic operations and like storing futures. It is a permanent data storage service. Then like cache futures, it's a cache at a memory level, and it has and can be set a life cycle. Then like canister futures, it allows tools to directly call the smart contract on the ICP. There are also things like HTTP futures. It allows tools to call external internet services through a collection of functions like kings, stores, and cache. It's all isolated. That means different agents or tours, they all have their own names. They don't interfere with each other. Then let's take a look at the agent contacts. On the left, it is available to the agent. The tour is not necessary. Not only does it include the context-based feature set, there's more to it, like what completion features invoke the relevant functions used to invoke the big language model, as well as embedding and so on. There are also runtime features. That is to say, it can call the tools that have been registered in the current image and other agents. It can even call remote tools and agents. So from the feature set of context, we can see type of tuple. It's just a pure function. It doesn't have the ability to invoke large models. You can use other tools. And the agent type, it is a complex function. It has the ability to invoke large models. You can also call other tools and agents. It can also call remote tools and agents. These tools and agents can be explicitly called. It can also be through large models, automatic invocation through suggestions from the large model. These are the basis for AI agents to combine and cooperate to form an agent network. Next, let's take a look at the agent and agent. It is the word and agent. It is a complete realization and code. It is also the core scheduling engine of and an agent can include multiple agents and tools. They're registered in the engine. It can be automatically scheduled by the engine when we need to add core functionality and functionality to the framework. We usually implement it in the project of an engine. For example, say adding some new general purpose atoms or tools, etc. The key difference between an AI agent and an AI application is that an AI agent is a mainframe. You have autonomy, then it must have its own ID. For the identity ID of the AI agent is the decentralized and trusted identity ID given by the ICP blockchain. That is the ID field above the context. This ID is and the identity of the agent, this and the identity of the agent, and wisdom. When the agents and tools inside the energy body called the canister of the ISP blockchain will use this ID to sign. When they use HTTPS signature to call other internet services, this ID will also be used for signing. The WebSecond servers can also verify the authenticity of this ID through the identity verification mechanism of the ICP blockchain. We have provided a Rust library for use by Web2 services as a Web3 AI agent, in addition to trusted IDs. Another key feature is security and privacy, and the encryption function, web-based AI agent. It may be through a configuration file to configure the key. The key is actually generated and held by the developer and is generated through the decentralized key derivation mechanism of the ICP blockchain. This is an absolutely secure method of key generation. None of the AI policy developers can obtain the key with this absolutely secure root key. Developers can implement a wide variety of encryption functions. For example, connecting to other blockchains, even issuing TLS certificates. Develop a certificate issuing AI agent using ENS framework is entirely possible because of SP and TED all can guarantee its authenticity and safety. Perhaps the greatest challenge is whether to pass the audit and certification of relevant authorities. And the framework's storage features are based on the object store protocol. This protocol is maintained by the Apache Arrow project. It is a general-purpose data storage protocol. Its backend can connect to many storage services. For example, AWS 3, Azure Blob Storage, Google Cloud Storage, and local file memory, etc. We use the lens vector database to implement the knowledge memory of the AI agent. Its backend is also stored by the object store protocol. So we implemented the object store protocol in the ECOS project. It also supports encryption. Therefore, the knowledge memory can be encrypted and permanently stored on the ICP blockchain. I know that there are also some implementations of vector databases on ICP. However, they cannot support encrypted storage. T-Compute provides hardware-level security, isolation, computing environment, and authentication for Android. At present, the HIT framework supports the neutral and clever of AWS through the ICT project. The future will also support Intel's SGX, NVIDIA, IAST 1 GPUs, and so on. Only running in DT. We can only believe and verify, and that it hasn't been tampered with. Its computing state, for example, keys and so on, are also in a secure environment. It cannot be stolen. For example, I cannot expose the encrypted image of the current and the ICP. So anyone can run it, but no one was able to steal the key and so on from it. Even if you run multiple instances, there will only be one under SE. Therefore, there is no need to run multiple instances. But there's an interesting property here. With the support of ICP and TA technology, I can expose a mirror program that contains classified information. Let others run along without having to worry about the leakage of confidential information. This was not possible before. Since we can put the running in TE, since we can run a iAgency, then in fact we can also run other programs. It's a border gateway. Another example is the development of a decentralized exchange based on TE. And in the project's technical documents, there is a sequence diagram detailed and shows the startup process in TE. So I won't go into details here. Finally, let's introduce the development roadmap of and although the framework was born from Web3, but it can also be applied to the usage scenarios of Web2. We will support non-T environments, but we will keep the identity and key derivation mechanism of the ICP. I also hope to take this opportunity to bring ICP into the scene of Web2. We will develop an ANDA website, provide more documentation and tutorials, make it easier for users to understand ANDA, let developers make better use of the Android framework. We will also integrate more blockchains, for example, Solana, ETH, BTC, Doge, etc. We will also develop more AI agent applications based on realistic application scenarios. We will launch a developer grant program and an ecological fund. We hope to attract more developers to join and thus ecosystem. Eventually, we will develop the AI agents cloud as a service, and it will gradually evolve into an agent network. So that's it for me. Thank you very much.